Start with that. Chalk. How's everybody doing? Good. Excited for the long weekend? I am extremely excited for the long weekend. It's extra long for me because I don't teach on Tuesdays and Thursdays, so I'm not back at work until Wednesday.
You love you.
I am late. All right. Are there any questions, comments, concerns, fears? Yeah. Oh yeah, you're like holding your pencil right there. Don't do that. We have our first thing due today. What is it?
Assignment 1.
Assignment 1, right? You guys have all finished it, right?
No, not yet. Sounds like we talked about it in the last
All right, we should get on. Yeah, and don't wait. Blackboard has issues. You think when you scan it, it's going to screw up. So what should you not do?
Wait till last minute.
Wait till like 11:58 to try to turn it in, right?
Okay.
It'll be late and you'll lose 10 points and then you'll be sad and you'll send me an email saying, it wasn't really my fault, it's just because Blackboard messed up. And I'll go look in your thing and it'll show me that you like waited until 11:59 to turn it in, and then I'll email you back and say, well, that's sad for you. And then you'll be mad at me, and then you'll get on, like, rate my professor and write some mean thing about me. We can just avoid that if you just, turn it at 11:30.
About accurate.
Source of truth hurts. All right. Any other questions? Anything that we've talked about up to this point? Cool. In that case, I thought it'd be fun to do a little warm-up problem. All right. Let's do this. Let's say f is a function of a, b, c, and d, and it's equal to simply a or b naught and c and d. What form is this expression in? Sum of products, right? So that's the sum of products. So what I'd like you guys to do right now is convert that to product of sums. The other one. Convert to product of sums. The chat. While you guys are working on that, what technique do we use to convert a sum of products into product of sums?
Second distributed property.
Ooh, controversy. Second or first?
Second. POS.
What do we got? What you got?
A and is the plus and or is it or?
No, flip it over.
A or B naught, and A or C and A or D.
Cool. How'd you get that?
I use the second distributive rule, treated A as X, B naught as
Hold on, hold on, hold on, hold on. You said X equal to A,
Y equals B naught, and Z equals CD.
C and D. And that got you what?
A or B naught and A or CD.
A or B naught and A or C and D. Then what? Yeah, hold on, what you got? No, it's fine. Yeah, it's all good. The
And
question
do
was,
we-
would it mess things up if you changed it instead? You know, did B naught C for Y and D for Z? And the answer to that question is no. You'll still get to the right answer in the end. What's up?
I put mine as where A or C and A or D were separated. Is that okay, or should it be in that form?
Wait, what do you mean? Well, we're not done yet.
Oh, all right.
Yeah, because we're supposed to do it one more time, don't we?
Yeah.
Yeah. So we're gonna do it again. This time, what's our? Well, first off, which one of these terms are we focused on now?
That's A or C and D.
Right, focused on A or C and D because A or B naught is already done. So in this case, what was our X? X equal to A, our Y was equal to C, and our Z is equal to D. And that got us, we still had A or B naught, but then that converted into A or C, or, excuse me, and A or D. And there we go. Converted into the product of sum. Any questions about that? Pretty straightforward, right? Good, hopefully it should be. So you did exactly correct. You applied the second derivative once, and you applied it again. I will say, a shortcut that you can use in the future is the second distributive can be extended out, right? So instead of just saying X or Y and Z, I could say X or W, Y, and Z, right? I can have as many variables here as I want, and it's still going to get me the same thing. X or W, X or Y, X or Z. Right, so by extending the second distributive property, we could do it in one shot. Right. Cool. Any questions about this? All right. So, next up, let's talk about, over here, complementing a Boolean expression. What do we mean by that? Complementing a Boolean expression. Do we mean, you know, what we tell the expression that looks really nice today? What does complementing mean? I believe you mentioned it once or twice.
Like the opposite.
The opposite. Taking the inverse, exactly, right? So complementing is taking the inverse of the thing. So we're taking our function, our Boolean expression f, and we're converting it into f prime. There are lots of reasons why we would want to do this. So to do this, we apply one of those properties, De Morgan's theorem, over and over and over again. Apply De Morgan's theorem. And that was X or Y naught is equal to what?
X9, Y naught.
Say again?
X9, Y naught.
Yeah, it's equal to X naught and Y naught. By that same token, X and Y naught is equal to what?
X9, Y naught.
Good. X naught or Y naught. I just saw someone in the Discord say that the board was a little cut off. There is nothing over there. It's like right on the line. I see already said that. All right. So that's De Morgan's theorem. So let's just do an example. Let's say we have f is equal to the quantity a prime or b and c prime. And we want to find the complement, f prime. So the first thing we do is we just take f and we stick it all in brackets, and we complement a naught or b, c prime, all of that prime. Okay, so if I apply a number to these two things, call this first one the one with the OR gates 1 and the one that's ANDed 2, which one of these versions of De Morgan's theorem do we want to use first?
2.
What's that?
2.
2. Let's use 2. And in that case, we're going to use 2. Our x is equal to what?
A prime or b.
Good. A prime or b. And our y is equal to
C prime.
c prime. Good. So that means that f prime now is equal to what?
A prime or b, all of that prime.
Yeah, right? So x is a prime or b. We want to get x prime or y prime, so that means it's going to equal a prime or b, all that prime, then what?
Or c.
Or c. Why or c? Why not or c prime?
Because the prime of a prime.
Exactly, right? Because we took, there was already c naught, so c naught naught, c prime prime is just c. All right, are we done yet?
No.
No. So what do we do now?
Use the first one.
We use the first one. And in this case, well, first off, which one do we care about?
First term.
First term. All right, in that case, x is equal to what?
A prime?
Good. A prime. And y is equal to b. So that's going to get us what?
A b prime or c.
Say those letters.
A b prime or c.
So A and B prime, and there's W or C. And now that we've got it back in sum of products form, we're good to go. Everything's finished. So that's all there is to it. Just apply De Morgan's theorem over and over again until you've reached the end. Any questions about that example? All right. So that's the way you do it. And 99 times out of 100, I say never like try to do anything in your head. But really, actually, complementing a Boolean expression is something you can do in your head. And I'll show you why. Let me just ask this. What do you notice?
Does complementing convert SOP to POS and vice versa?
What's that?
Does complementing convert SOP to POS and vice versa?
Yes. But not on purpose. Because remember, so that's a dangerous question, right? The question was, what? Well, does complementing convert it from product of sums to sum of products and vice versa? And the answer is yes, but not on purpose. And it's dangerous because is this expression equivalent to f?
No.
Well, they have the same truth table. See some shaking of heads. And someone on Discord said, no, you're absolutely right. It's not the same. This is f prime. It's going to have an inverted truth table from f. So while yes, the forms, if you start with one standard form, your complement will end up In the other standard form, it is not a conversion. We're not converting from one form to the other because we're flipping the function over. We're changing the truth table. So you can't use this as a technique to convert from one form to another. Go back to this question. What do you notice about f and f prime? If you look at what you started with and what you got, you notice anything interesting?
Take the inverse of everything.
The inverse is everything, right? Everything is flipped over. Everything that's inverted is non-inverted, and all the ors became ands, and all the ands became ors, right? Does everyone notice that? So we had A naught or B, that became A and B naught. O and C prime became or C. Did everybody see that? All of the operations flip over. So if I give you a function like this, let's say A B prime or C and D prime or E, right? That one might be cut off. That's F. What does F prime equal to? Can anyone do it just in one shot?
This is inverse everything.
What's that?
So you just inverse everything?
Yeah. What does that get you? By the way, if you can't do this, it's not that big a deal. You can always just go back to using the correct process. This is just a shortcut. What you got?
Is it A prime or B in parentheses and C prime, or can I just put the and C prime directly after that?
No, because that wouldn't be the same, right? So we started off, so A, he's talking about this quantity in here. A and B prime or C is going to become A prime or B and C prime.
Or D and E prime.
What, say it again?
Or D and E prime.
Now, is it this D and E prime? Is that correct? Susan nodding, this is shaking. No, right? Because this or is sort of covering all of that. So you're gonna take the whole thing. And good Lord. E prime. So it can be a little tricky when you have to keep track of like what's grouped together. But with a little practice, it's pretty easy. Alright. Any questions about that? Yeah, like I said, if you can't do that, don't worry about it. There's always the correct process. This is just a fun short. Okay. So, I'll just keep chugging along. I want to introduce one more simplification theorem that comes in handy sometimes. And it has to do with when we're trying to multiply out to get our our sum of products form. So I'm going to title this a new theorem for multiplying out. So we have the first derivative for this already, but sometimes we can get stuck and get some forms that are kind of weird. And in that case, we're going to use this theorem. X or Y and X naught or Z is equal to X and Z or X naught and Y. So what that means is if you have, first off, what form is this? Sum of products, product of sums. Product Product of sums, good. So we have this product of sums, and we have the thing and its inverse, and two different things. We can combine them, right? The x goes to z, and x prime goes to y. Sort of a weird theorem, right? So let's go ahead and put it in practice. Can I erase this afterward?
So it's not like foil or something?
What's that?
So it's not like foil? And then like dark,
I mean, it's kind of like FOIL, right? It's just we're going to skip some steps because, well, I don't know, that's sort of worth doing. What if we FOILed this out? So x or y and x prime over z. We did FOIL, right? First, outside, outer, inner, last. Is that what it is, right? That would be x and x naught, or in the outer x z, or x naught y, or yz. So there's two things that happen here, right? First off, what is x and x naught?
0.
And goes to 0. What about the last three terms? What theorem is that? The consensus theorem, right? And when we see the consensus theorem, what term is getting eliminated? Yeah, y and z is gone. My consensus. So yeah, so when you FOIL it out, this happens naturally, and then apply the consensus theorem, you get that result. This is one of those cases where this happens a lot, and so they gave us a theorem just to use as a shortcut. All right, let's go ahead and simplify a long and disgusting expression. All right, let's say that f is equal to, bear with me, A or B or C prime, and A or B or D, and A or B or E, and keeps going and going again. A or D naught or E, and A naught or C. And we want to simplify. We also want to convert it to product of sums. Or excuse me, sum of products. So, what on earth can we do with this thing first? What you got?
I just have a question.
Yeah.
That was product of sums, the top part.
The left-hand side of the top part was, yeah.
Was the, yeah.
That one is product of sums. This one is sum of products. You're welcome. So we're starting with what form? Good, product of sums. All right, so what should you start looking for? You got an expression, it's big, it's long, it's gross looking. But you got to start paring it down. What should you look for first? Say again?
Oh, a common variable.
Common variable, yeah. Things where, places where stuff is the same, right? Because that's where your theorems are going to eke out. So where are some places where stuff is the same?
A and B, yeah.
Say again.
A.
Well, A, yeah, not just A.
A plus B. Oh, yeah.
Plus B.
Or B.
Yeah, right, we have A or B, that appears here, and here, and here. So again, remember the rule, still always to apply that first derivative. So what are these three terms going to condense down to? Oh, I would use the second derivative, or second distributive, not derivative.
So this is gonna be AB plus BA.
AB plus what?
This is the second part.
Oh, let's see. We're not there yet. We're not using that one yet. Not for this part.
Plus there's a third.
What's that?
There's a C on the left side, and the other side just has two terms.
C on the left side.
You know how it's A plus B plus C prime?
Yeah.
Oh no, we're just looking at A and B, right?
We're just looking at these. I'm asking you guys to consider just these three terms. I think you're overthinking it a little bit. What you got?
It would be, A or B, and you add that to C prime and B and E like that.
Yeah. Remember, we just talked about this. If we have X or W and Y and Z, right? That second derivative, that's sort of expanded second derivative. What does that get us?
X or W, X or Y, and Z.
X or W and X or Y and X or Z, right? So in this case, what's our X?
A or B.
X is A or B, right? And then we have what? We have a W that's equal to what? C prime. A Y that's equal to D, and then a Z that's equal to E, right? So that's going to get us what?
Like
A or B.
Or C.
A or B, or
C prime.
C prime, D, and D, and D. Good. Not too bad, right? And then the rest of the stuff. A or D prime or E, and A prime or C. Okay. Now let's take a look at the other two terms. Right. These guys. Now these guys can be simplified using that new theorem we talked about.
Substitute E prime or E to one variable for these theorem.
Yep. So in this case, what's our X? Yeah, X equal to A. Since we have A and A prime. What do we use for Y? Say it again.
D prime and E.
D prime or E. Makes our Z what?
C.
Just C. Good. All right. That makes the next line. We'll go ahead and add this stuff: A or B or C prime or D, excuse me, and D and E. And here, what are we going to get? A and C. Or
A and B prime plus E.
Try one more time.
A and D prime or E.
Try A.
A
prime.
A prime, good. A prime and D prime or E. All right, that was pretty dense. What questions do we have about how we got to here? What you got?
Should we distribute the A prime across the D prime and E?
We should more do that, yeah.
We should.
So I guess we do that now. Here we go. Equals A or B or C and C prime and D and E and A and C or A prime and D or A prime and E. All right, come on, let's chalk this next part. So, everybody good? How we got to this point? Yes.
Is that supposed to be A prime, D prime? For like second term in the second?
Right. What happens next? It's not there yet, we're not in some products.
The Morgan law again.
De Morgan's. Not De Morgan's. There's no common set. Sometimes you just gotta distribute, man. It's gonna suck. It's gonna take a second. But you gotta just do it. Right? And what do I mean by that? Right? Where we multiply everything in here by everything in here. Or excuse me, and everything in here by everything in here. Foiling on steroids. Like I said, sometimes it's the only thing you do. Alright, so, well, let's do that. And then we'll simplify after that. So we have here, so I'm gonna start with the left-hand term and do this and that and that and that, and then work my way down. What I mean by that is it's gonna be A and C, or A and A naught and D naught, or A and A naught and E. Move to the next term. B and A and C, or B and A prime and D prime, or B and A prime and E, or C prime, D and E and A and C, or C prime and D and E, and A prime and D prime. E to the other side of the board. Or the last one, C prime and E and A prime and E. There we go. That's too bad. Does everyone understand what I just did? It was long, but it wasn't terribly sophisticated, right? All I did was foil everything through, yeah.
Like, when you just decide to like, you know, do too big, you do that, you let it go?
You take a look at it. We might not get it today. Probably on Wednesday we'll talk about like a more sort of formulaic approach to take. I'm gonna try this first, and then I'll try this first. Sometimes you look at it and say, yeah, I don't see anything. Just do it. Yeah. Yes.
With the A prime, or A and the A prime and B pull out, because A and the A prime is always going to be 0 and B.
You're absolutely right. Yeah. So there's some simplification we can do right now, right? It makes it pretty easy. So for example, A and C is what?
EC.
Is A and C. Right? Because anything X and X is equal to X, right? So, what about A and A prime and D?
0.
Oh, this is 0. What about A and A prime and E?
36.
Also is 0. Then we have BAC. Now there is no rule that says you have to do this, but it's just a matter of style. It's always kind of considered good practice to write your variables in alphabetical order. So we'll change BAC to ABC. or B and A prime and D prime. There's really nothing we can do there, right? A prime, B, D prime. Then A prime, B, and E. Then we've got some stuff. C prime and D and E and A and C is going to go to what?
0.
It's going to go to 0, right? Because it's C prime and C. Then we have C prime, D, E, A prime, and D.
0.
It's going to go to 0 too, right? Because it's D and D prime. And then finally, this last one, C prime, D, E, A prime, E.
You can take one of the e's out.
Yeah, right. So we can have A prime, C prime, D, and E. All right. I'm going to double check my notes to make sure we don't screw that up. C, A, B, C, A prime, B, D prime, A prime, B, E, A prime, C prime, D, and E. Cool. All right. Questions so far? All right, I'm going to need this side. So here's my first question. Have we arrived at a standard form? Is this in sum of products?
Yes.
Yeah, it is. There is a little bit more simplification we can do. In fact, there's one more simplification we can do. Well, there's one more simplification that we're going to do. Does anybody see it? What's that? Combined terms? Yeah. What terms?
Like,
Okay. Which like terms? It's not A. What was the uniting theorem?
X over Y and X.
Yeah, right. Uniting theorem said X or X and Y is equal to X. What's that?
Oh, I guess I was doing
Is that included?
Is that absorption? Oh, it might be. It is absorption. My mistake. Fred. There's absorption here. Uniting is the other one, which is what X and Y or X and Y not is equal to X. Yeah. Talking about absorption. These two terms. Can we apply the absorption theorem there? Yeah. What's our X?
AC.
Good. X is equal to A and C, and our Y is equal to
B.
B. So that means these two terms simplify to be what?
AC.
Just A and C, right? So we eliminate that term. And it's or the rest of that stuff. Yeah.
Can you not do it for the next two terms?
Oh,
never mind.
that's a good question. No, we can't. Why not?
Because there's a D prime in it.
Right? Well, there's something there, right? There's A prime and B, or D prime, excuse me, D prime, or A prime and B and E, but it's not quite because it's not the same thing.
Mm.
Okay? It's not the inverse of something. All right. Don't worry about that. Any other questions about this big example before we move on to something completely different?
What we included? Oh, everything else is.
Yep. All right, next up it is time to add a new operation. We have and, we have or, we have not. Today, for the last sort of 10 minutes, I'm going to add exclusive OR. And equivalence. Let's talk about exclusive OR first. So the symbol for exclusive OR is just like a little crosshairs. Circle with cross drawn through it. Who knows what exclusive OR means?
Is that where it's only one of them can be true for like
What's
both
that?
of them to be true?
Say it one more time.
Like if it's like A exclusive or B, it's either one of them has to be true and they can't both be true.
They can't both be true, yeah. So if I say X exclusive OR Y is equal to 1 if and only if X equals 1 or Y equals 1, but not both. So it's 1 or 0 or 0 1, but not 1 or 1. So if we draw the truth table with X and Y and X or Y with 0 or 0, 0 1, 1 0, 1 1. All right. When X is 0 and Y is 0, what's exclusive for?
0.
0. If X is 0 and Y is 1, exclusive OR is
1.
1. X is 1 and Y is 0, 1. And if X is 1 and Y is 1,
0.
exclusive OR is 0.
Pretty cool.
What's that?
Pretty cool.
Yeah, pretty cool. So it has an algebraic definition, right? Because remember, we always need to get back to our standard forms. So if I say, let's do this, X or Y, exclusive or Y, how do we write that as an algebraic expression? X exclusive OR with Y is equal to 1 if and only if X is equal to 1 or Y is equal to 1, but not both. Can anyone state that as a Boolean expression?
X prime Y or X Y prime.
That's the punchline. That's what it simplifies to. So yeah, you got the right answer. But what I was looking for was, one of the things we're going to work on starting next week is like taking like sort of English sentences and like making Boolean expressions out of them. So what I wanted to do is say it's equal to 1 if and only if X is equal to 1 or Y is equal to 1, but not both. So what I was looking for was this. Exclusive OR is equal to X or Y and not X and Y. See what I mean? It's got more of a semantic ring to it, right? Now that's not a standard form, so we need to put it into a standard form, which is where we'll get her solution. And what can we do with that? Convert this into sum of products. First things first, if you see any group of anything complemented, what should you immediately think? De Morgan's theorem, right? So X and Y prime is going to be equal to what?
X prime or Y prime.
Good, so it's X or Y and X prime or Y prime. We can distribute these fellows together, right? We can FOIL them, that gets us X and X prime, or X and Y prime, or X prime and Y, or Y and Y prime. What happens to X and X prime?
Goes to 0.
It's gone, it's 0. We just have X and Y prime, or X prime and Y. What happens to Y and Y prime?
Goes to 0.
Also goes to 0. So there we go. Sum of product solution, X and Y prime, or X prime 1. Oop. That's out. All right. So a couple of last thoughts, and I guess we'll pick up with statements on Wednesday. Is that? This is what about you? Yeah. Okay. The circuit schematic symbol for XOR, and by the way, the shorthand name for this, XOR, is XOR. And if anyone says XOR in my class, you gotta get at it. It's XOR, it's not ZOR. I don't care what your high school computer science teacher said.
Does X or R?
It's XOR.
Okay.
Yeah, I spelled it. I realized that made it more confusing, but
Yeah.
yeah. So what we have is X, X, and Y. It looks like this. It has like an extra line attached to an OR gate with that OR gate symbol drawn through. And on the outside is X, X1. Cool. All right. Any questions about that? Yeah.
So XOR is exclusive OR?
Yes. All right. Any questions about anything we talked about today?
Pretty freaking cool.
Pretty cool. Okay. In that case, have a good long weekend. Be safe. Don't forget that your homework is due tonight at midnight. Do that before you skip town. And I'll see you guys on Wednesday. Be safe. Don't do anything stupid. Don't get sick. Well, Devin, I was going to answer your question, and you said XOR.
All right, bye. Have a good weekend.
You too. Thank you.